So let's start putting the circuit together. First of all, we'll use our ground and power rails. So we can push this into ground and into ground on the breadboard. And then our 5 volts into the 5 volt power rail. So next we'll take our 3 LEDs that we've got and start putting them in. So we'll put them all in so they're facing the same way, so that makes wiring it up easier. So we've got the shorter leg is on column E. So this is the short leg here. And so the second one, and then finally a lovely blue one. So we've now got our LEDs. They're sitting across the channel, so the legs aren't going to be connected. And now we can look up wiring them up. So this side of the LED we will connect to ground. So we'll do that 3 times over. And then for the blue, so you want to make sure that the leads are in the same columns, in the same rows as the LEDs. And then we want to put our resistors in. So you want to bend those into your U shape and place them in. Now if we place a little bit back from the edge, that'll make wiring to the digital pins on the Arduino easier. And so one for the red. So it doesn't matter which row you choose to put them in, just make sure that you don't have, for example, these leads here touching, and make sure that wherever you end up is not already occupied by one of the other component legs. And our final one for the green. So, to review, we have at the moment our ground rail coming into the jumper and going into row 5, across to the short leg on the green LED, which then goes across the channel onto the row 5 still on the other side and through the resistor. And then we repeat that for the red LED, which is in row 11, and having a resistor going to row 14. And then finally for the blue LED, which is in row 17, and going into this resistor. But it's not, and so you'll notice here that in fact we have it going into row 17 here and row 18 here. So that won't work. So we need to fix that by making sure that it's in row 17. So that's a good example for why you need to go through and just double check your wiring when you're doing these things, because it's easy to put them into the wrong row by accident. And then finally, we want to connect the resistors to the pins. So I've chosen for our signal wires having 3 different colors that are kind of related to the colors of the LED. So we've got a green one, a blue one, and an orange one, which we'll use to connect to our red one because we're already using red for our 5 volts. So let's start by connecting the green one, and we will connect this to pin 8. And then we will connect our red LED into the orange, and in fact that's not quite going to fit, so let's move that along this way. So we've moved it so that it's slightly closer to the board, so we've now got it going from the red lead into the resistor on row 11 and going into row 8, and then we'll connect from row 8 into digital pin 9, and I'll just grab a longer one for the blue one, and so we can connect from row 21 into pin 9 for the blue. So now we can check out our circuit. We can work backwards from pin 10 over our blue wire into the resistor on row 21, through the resistor into row 17, along row 17, up through the LED and up through the black jumper to the ground, and then ground goes back to ground on the Arduino. So note again, we're not actually using the 5-volt line. Then we can repeat the check for the red one in pin 9, which goes through orange into the row 8, along row 8 through the resistor into row 11, along row 11 through the LED, the long leg, out the other side onto row 11, through the black jumper, and then into the ground rail again. And then finally, with the green, it goes from pin 8 through the green jumper, along the resistor on row 2, through the resistor onto row 5, and then through along row 5 through the green LED, and finally through the jumper into the ground rail. So now that we've got the hardware for this sorted out, we can look at the sketch. So we're going to use one of the existing examples to base our new example on. And that's one of the great things about the number of examples that ship with the IDE, and also the number of examples that you can find out on the internet that people have put up there for other people to use and make use of. So we're going to use the blink sketch again. Now at the moment we're using pin 13 in our sketch, and we're actually using pins 8, 9 and 10. So there's a number of ways that we can handle this, and if we were going to be doing a lot of work like this, we would use something called an array to hold the different pin values. But because it makes it a little bit simpler to understand, for this example we'll just use separately named variables. But if you find yourself wanting to control 8 LEDs, say, then you want to look into how to work with arrays. So let's change this to be red LED. And our red LED is in pin 9, so we'll change that to a 9. And then we can copy this and do the same for blue, which is in pin 10, and green, which is in pin 8. And then we also want to make sure that we set the pin mode for each of these to be output as well. So we make that the red LED is an output, the blue LED is an output, and the green LED is an output. And then finally, we want to turn them all on and then turn them all off. So we turn our red LED on, and then repeat that 3 times for blue LED and green LED. And then we want to turn them all off again 1 second later. Red LED off, blue LED off, and green LED off. So because we've made quite a few changes, let's change our sketch again. Now you'll notice that when we go to save the sketch, that it automatically opens up what is known as the sketchbook. And so this is one location on your computer where all of your different Arduino projects can be saved. So you can set that in the preferences if you don't like the default location. It's also a location where you can add additional libraries which add more functionality to your Arduino as well. So we'll call this our my multiple blink and save it. So now our sketch, we're using pin 9, 10 and 8, and we're setting the pins to all be outputs, and then we're turning them on, waiting a second, and turning them off. So, what do you think is going to happen when we connect it? Let's find out. So, we want to use our USB cable, connect it in, and then upload it. So it compiles our sketch and uploads. Once again, we get the sketch uploaded, and then we have our LEDs turning on and off. So we've got our green one working, our red one working, and our blue one working. So perhaps you'd like to change the order in which they turn on and off, or go through a particular sequence. So let's look at turning on the LEDs at different times. So we can come in here and say, well, okay, we want our red LED on, and then we want a delay of, say, half a second. So 500 milliseconds. We'll delete that comment because it's no longer accurate. And then we will turn it off again. And then at the same time as we turn the red LED off, then we can turn the other LEDs on. And then wait for a second, and let's say that we want to keep the blue LED on a little bit longer, and then turn it off again at the end. And then, if you remember at the beginning, we need to make sure that we include a delay at the end of the loop if we want to, so let's include a longer delay there. So now we're going to be turning on our red LED, and the other LEDs will be off. And then half a second later, the red LED will turn off, and the blue LED and the green LED will turn on. And then a second after that, the red LED, which is still off, so we don't need that line, the green LED will turn off. Then half a second after that, the blue LED will turn off, and then it'll wait, and then it'll go through the sequence again. So let's try uploading that sketch. So we upload, we see the TX and RX lights flashing, and then we have a different sequence of LEDs. So we've got our red light turning on, and then our green and blue, and then finally the green and blue turn off. So in the next section, we'll look at how you can independently control each LED, and how you can have other things happening. Because at the moment, because we're using delays, as long as we're using delays, nothing else can happen. And so once you start interacting with sensors, you really want to be able to detect something and then turn an LED on, and then do something else, and then check to see whether it's time to turn the LED off again. So we'll look at that next.